Hello, everyone! In today's rapidly evolving software landscape, building scalable and resilient systems is no longer a luxury, it's a necessity. Think about the massive services you use every day, like a global e-commerce platform or a streaming giant. They operate flawlessly because of sophisticated hidden coordination. Today, we're going to pull back the curtain on that complexity. Our lesson, Mastering Distributed Coordination with Spring Cloud Commons, will equip you with the knowledge to build systems that are not just robust, but truly intelligent. By the end of this session, you'll have a clearer understanding of the core mechanisms that make distributed systems hum and how Spring Cloud Commons simplifies their implementation. You'll gain practical insights into solving some of the trickiest problems in microservices architectures, moving beyond just basic failover to true coordinated intelligence. Let's dive in. Imagine a major search engine handling millions of queries per second, or a massive social network processing countless updates simultaneously. These operations seem effortless, but beneath the surface lies an intricate dance of coordination. Our first key takeaway is that modern distributed systems inherently demand sophisticated coordination. Without it, chaos reigns. You might have implemented basic failover mechanisms before, a spare server ready to take over if the primary fails. But here's a crucial insight. Raw failover is often insufficient for complex stateful scenarios. It's like having a spare tire but no jack or wrench. You need to know when and how to switch and ensure data consistency during the transition. That's where coordination abstractions come into play. This is precisely why Spring Cloud Commons is so powerful. It provides battle-tested abstractions for the hardest problems in distributed systems. It gives you the tools to manage shared resources, schedule tasks, and maintain consistency across independent services, turning potential chaos into a perfectly synchronized operation. It's the hidden orchestrator that makes everything work. Let's dive into the first core abstraction, the distributed lock. Think about a scenario where multiple instances of your service might try to update the same customer record or process the same payment. Without coordination, you're headed for data corruption or inconsistencies. This is where distributed locks ensure exclusive access to shared resources. Just like a physical lock on a door prevents two people from entering a room simultaneously, a distributed lock ensures that only one service instance can operate on a specific resource at any given time. This is absolutely critical for preventing conflicts in concurrent operations. Consider a ride-sharing application. When a driver accepts a ride, you need to ensure that driver isn't simultaneously offered another ride or that the same ride isn't assigned to multiple drivers. Uber's ride matching, for instance, uses distributed locks to prevent exactly this kind of race condition, ensuring a consistent and reliable experience. Ultimately, distributed locks are fundamental for maintaining data consistency across services, especially in high-throughput environments where data integrity is paramount. Spring Cloud Commons makes implementing these locks straightforward, abstracting away the underlying complexity. Moving on to our second crucial abstraction, leader election. In many distributed systems, you have tasks that should only be performed by one instance, even if multiple instances are running. Think about a scheduled cleanup job or a batch process that aggregates data. If every instance tried to run it, you'd have redundant work, or worse, conflicting operations. This is where leader election designates a single active instance among many. Only the designated leader performs the critical tasks, while other instances remain as passive standbys, ready to take over if the leader fails. This pattern is vital for coordinating batch jobs and scheduled tasks. For example, Spotify uses leader election to coordinate massive playlist generation jobs across its global data centers, ensuring that each part of the process is handled uniquely and efficiently. It ensures unique execution of critical processes, preventing duplicate work and maintaining system integrity. Spring Cloud Commons simplifies this by providing events for when an instance is granted or revoked leadership, allowing you to easily start and stop specific services or tasks based on its leadership status. This ensures your critical operations are executed exactly once by the right service instance. Now that we understand the core abstractions, let's look at how you'd implement them and what makes Spring Cloud Commons truly brilliant. First, for distributed locks, you can implement with flexible lock providers like Redis for high-performance, short-lived locks, JDBC for durable, database-backed coordination, or Zookeeper for complex distributed scenarios. The beauty is you can switch providers without changing your core application code. Second, Spring Cloud Commons offers seamless integration with the Spring ecosystem. Auto-wiring and configuration are simplified, allowing you to focus on your business logic rather than boilerplate code. Third, it boasts built-in resiliency and observability features. This includes automatic retry mechanisms, graceful failover, metrics, and health checks right out of the box, drastically reducing the effort needed to build robust systems. These features are game changers for ensuring your applications are not just functional, but truly production-ready. So we've covered the necessity of coordination, the power of distributed locks, and the elegance of leader election. You now have a solid foundation for building highly reliable distributed systems. To wrap up, think about this. How do distributed locks and leader election contribute to making a system more reliable and consistent in the face of failures or high concurrency?